Hello friends, this is Jim with Science Talk. I have been doing some reports, sharing some reports with you lately about what it means, what a warming planet means in terms of agriculture and harvest and so forth. I just did most recently a segment where studies are showing that rice is becoming less nutritious. And there are some people out there, I see it on the online forums, that, oh, warmer planet means greener world, it's great for agriculture, this and the other thing. And the person obviously does not know what he's talking about. I pointed him in the direction of the studies indicating less nutritious plants, as well as the story I'm about to share with you now. Shrinking harvests likely as heat increases. A warmer world could mean shrinking harvests and a more meager diet for millions of people, according to two new studies. So, a hotter world could also mean a hungrier world. So, a hotter world does not translate into being able to grow more plants. It might actually mean the opposite, because shrinking harvests poor quality plants. As planetary temperatures rise, climate change could lower the yield of vegetable and legume crops, at the same time reduce their nutritional content. Legume crops are important crops. The same increasing temperature could raise the risk of massive near-global losses for the world's most widely grown crop, maize, what in the U.S. is called corn. That would be catastrophic. This 1-2 punch, if you will, is based upon the evidence from field trials over many years. And I've already reported to you on this, but it's being reported here, that another global staple, rice, is likely to become less rich in proteins and vitamins as temperatures increase. British researchers report in the Proceedings of the National Academy of Sciences that they studied 174 research papers based on 1,540 experiments in 40 countries between 1975 and 2016, so basically a 40-year period, on the probable effect of changes in water supplies, ozone, atmospheric carbon dioxide, ambient temperatures on vegetables and legumes. Now, I have done prior segments that kind of address, an aspect of each one of these factors I just mentioned to you. And please go check out those videos. They found that on the basis of changes predicted for later this century, 21st century, average yields of vegetables could fall by 35%, and legumes by 9%. Now, there has been some evidence that more atmospheric CO2 could fertilize more plant growth, but there are other accompanying changes. Greater extremes of heat, drought, flood, and so on could cancel out any such gains. Let me pause there for a moment to kind of explain why this is. There are two major types of plants. There are plants that have what's called a C3 metabolism, and there are plants that have a C4 metabolism. Now, basically what this means is that in the plant's biochemistry of taking CO2 and water and going through a whole bunch of reactions involving what's called the electron transport chain, which is where the chloroplasts come in, and in the whole process of making glucose at the end product, which is food. In the C3 plants, there's a 3-carbon compound that's intermediary. In the C4 plant, there's a 4-carbon compound that's intermediary. May not sound like much of a difference, but it has significant differences. The C3 plants are the ones we typically grow. Things like soy, wheat, barley, and so on. C4 plants are plants that are typically found in desert locations. So other things that are observed with these plants is that the C4 plants have First of all, they have reduced leaves to reduce transpiration, water vapor loss. They also have fewer number of stomata. Stomata are the openings in the leaves themselves from which transpiration, which is exchange of gas, CO2, O2, takes place. C3 plants have broader leaves, more stomata openings. So what happens is, as you make it warmer and warmer for the C3 plants, there's more water loss from the stomata. That does not serve the plants well. Also, the warmer temperatures is not these plants' preferred temperature range. The C3 plants, which the great bulk of our agricultural products are of those type, they kind of don't like temperatures above 80, 85 degrees Fahrenheit. Now we're starting to push temperatures into the 90s and lower hundreds. This is going to adversely affect such plants. And while this article does not discuss that, they're basically reporting the ecological end of things. I'm kind of sharing with you at least a brief glimpse into physiologically what's going on with the plants. I don't want us to turn this into a biochemistry class on the chemical pathways to make a C3 and C4 plant. If you're so inclined, you can go look that up in a botany textbook or a biochemistry textbook or something. And you will see all the gory reactions and chemical compounds and so on. I do not profess to be an expert on it, but I do know the difference between the C3 and the C4 plants, as well as what it means from an ecological aspect. I am an ecologist. So that's basically why we will be expecting, why there's the prediction of reduction in crop yields. That's basically why. It's getting too warm for these plants. Plants, like mobile organisms, have preferred temperature ranges. We're getting out of their preferred temperature range. Pauline Schielbeck, who's of the London School of Hygiene and Tropical Medicine, who led the study, called the finding a real threat to global agricultural production with likely impacts on food security and population health. Scientists have been warning for at least 5 years of the potential impact of climate change on agriculture and food supply. Other studies have shown that fruit and vegetable supplies could be at risk. There has also been evidence that heat extremes could damage wheat yields while endangering food supplies across the whole of Africa, and at the very least test the capacity of global markets to cope with sudden harvest failures across whole regions. Okay, the bit about wheat yields being compromised, that wheat is a C3 plant. It goes right to that aspect. Second study. U.S. researchers report, also in the Proceedings of the National Academy of Sciences, that they took another fresh look at the responsive markets to what they call volatility in the global crop of, basically, they focus on one crop, corn, maize. Corn is grown everywhere, basically, as long as there's suitable conditions. It is a staple for humans as well as livestock. It provides oil for cooking, and in recent years is being turned as a biofuel, for motor vehicles. And it's traded worldwide. In 4 countries, the US, Brazil, Argentina, and Ukraine, these 4 countries account for more than 85% of all corn exports. Right now, the chance that all 4 of these countries could have or would have bad harvest in the same year is almost zero, but if the planet warms 2 degrees C, this risk would rise to 7%. If global temperatures rise by 4 degrees C, which is what we are on pace to create if we continue on as we are now. We do nothing, we keep going as we are going, temperatures that the model will indicate temperatures will increase 4%, 4 degrees C, excuse me. then what happens is the harvest failure rates rises to 86%. So 7% at 2 degrees C to 86% at 4 degrees C. And of course, what would we expect happen to prices of, say, corn and other plants? Go through the stratosphere. Okay. So again, this whole business, oh, what's, a couple of degrees doesn't really matter. Yes, it does matter. It matters big time. Okay. 4 degrees C is 7.2 degrees Fahrenheit. As an example, Alaska has warmed by 4 degrees C over the last 4 decades. This is allowing spruce beetles to go further north because it's no longer severely cold to kill the larvae. So now they can go further north. The past 2 winters in Fairbanks, we have not seen a single day of minus 40 degrees. Not a single day. Now, it's good for my heating bill, but we used to get weeks of 50, 55, 60 below. Weeks on end. You have the high pressure system that's sliding over from Siberia, sets up shop over interior Alaska and the Yukon Territory, and you're basically waiting for that damn thing to erode as it slowly rotates. Only be replaced by something colder, right? So, but it's like, oh, here comes the high pressure system. It ain't going to be budged. And nothing's going to budge that until it erodes, and then maybe something else replaces it. You need to get 3 weeks solid, 50, 55, 60 below. Now, if we get a cold snap, it might be 45 degrees, it might last 3-4 days. That's what change of 4 degrees C. When people think about climate change in food, they initially think about drought. But it's extreme heat that's very detrimental for crops, said Michelle Tigchlar of the University of Washington, who led the research. And the extreme heat, for the reasons I just explained, basically the type of metabolism that takes place within the cellular machinery of the plants is the reason. C3 versus C4. So, she goes on to state, we find that as the planet warms, it becomes more likely for different countries to simultaneously experience major crop losses, which has big implications for food prices and food security. Another example of things coming home to roost. And how we are drastically changing our environment. And it's going to have direct impacts on civilization. Thank you for your time. We'll talk soon. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos. Please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below. Thanks.